Max Born was not a man of spectacle, but of structure. Born in 1882 in Breslau, Germany, into a family of academics, his destiny seemed etched into equations before he ever touched a chalkboard. He was quiet, precise, and deeply thoughtful, more intrigued by the invisible latticework of nature than by its visible beauty. This affinity for order led him to Göttingen, where his collaboration with some of the century's greatest minds, including David Hilbert and later Werner Heisenberg, would change the foundations of physics forever. Born's most pivotal contribution came during the turbulent early days of quantum mechanics in the 1920s, when the very nature of reality seemed to be unraveling. Classical mechanics could no longer explain the behavior of subatomic particles, and physicists scrambled to replace Newton's clockwork universe with something far stranger. Werner Heisenberg had formulated a bold new matrix mechanics, but it lacked a clear physical interpretation. It was Born who stepped in with the most crucial insight. The square of the wave function did not represent the particle's position itself, but the probability of finding it there. This probabilistic interpretation of the wave function was revolutionary. Until then, physics had thrived on certainty, predicting where planets would move, how forces would act. Born's idea was that nature, at its core, did not yield certainties, but probabilities. His 1926 paper proposed that quantum mechanics didn't predict what would happen, only the likelihood of different outcomes. It was an unsettling but brilliant reimagining of science's role, less a dictation of fate, more a whisper of possibility. This interpretation wasn't universally welcomed. Einstein, in particular, bristled at the idea, famously telling Born, "God does not play dice." But Born remained steadfast, confident in the mathematical elegance and empirical success of his theory. And he was right. Today, his probabilistic view is a cornerstone of quantum mechanics, shaping everything from quantum computing to the structure of atoms. In 1954, Max Born was awarded the Nobel Prize in Physics, not for discovering a new particle or devising a grand experiment, but for an interpretation, an abstract, philosophical shift that redefined reality. In many ways, Born's legacy is not just scientific, but existential. He showed us that the universe is not a rigid machine, but a realm of shimmering potential, where chance and order coexist in delicate balance. And in doing so, he left us with a humbler, more mysterious understanding of the cosmos.